Hi, it's 1T, and in this video we'll be solving equations, finding zeros, and problem solving. Now this first page is really just a quick review. Our focus is going to be on problem solving. We really assume in this course that you already know how to solve equations, and so it's important that you get up to speed if that's not the case. So let's just run through a couple of quick equations, and I'll just share my approach that I use when I teach this to students. Excuse me. So first of all, our goal when solving equations is going to be to get the variable by itself. So in this case, you're going to need to get rid of the minus 12. And in doing that, we have two principles. One is whatever you do to one side, you do to the other. Meaning if you add some number to both sides, or to one side, you got to do it to the other side. You can do that with subtraction and multiplication and division. So in this case, the other principle is what I call the principle of opposites. So we're going to use that as well. So I'm trying to get n by itself, and to get rid of this minus 12, the opposite of subtracting 12 is adding 12. So we'll add 12 to both sides. And notice the 12 minus 12, or a minus 12 and a plus 12 is going to give you 0. 0 plus n is just n. On the other side, 12 and a minus 6 gives you 6. And so we say the solution to this equation is 6. Notice if you plug in 6 for n, 6 minus 12 does equal negative 6. You can always check to make sure your solution works. So I would call this a one-step equation. It took us one step to get this solved. This is what I'd call a two-step equation. Now notice we're going to have to, in order to get x by itself, we're going to have to divide by 3, and we're going to have to subtract 7 on both sides. Now I'm going to write this really lightly here. If you divide by 3 on both sides, you got to divide the whole side by 3. We'd have x plus 7/3. This is only going to complicate things. So maybe we don't want to divide by 3 yet. Maybe we should subtract 7 first. So let me do that. And notice now we get a much nicer equation. In fact, with two-step equations, I always tell students you always want to add or subtract on both sides first, and then do your multiplication or division. And you can see here the answer is negative 3. So if you want to be good at solving equations, I always tell students, number one, you got to be able to solve one-step equations. Number two, you got to be able to solve two-step equations. And then I show people what I call the CSI method for solving multi-step equations. And basically, if you do 3 things, you'll always end up with a one or two-step equation, and then you should be able to solve that. So let me just, excuse me. All right, CSI. C is for clear fractions, which we won't do in this video. If we have fractions to get rid of, well, actually we'll do that when we get into zeros. So we'll talk about that at that time. S is for simplify. So the next thing to look for if you don't have fractions is to simplify everything you can on each side of the equation. And then finally, I is for isolate. What that is indicating is if you have x on both sides, you got to get it on one side. So let's go ahead and solve this equation using CSI, and once we've done those 3 steps, we should have a one or two-step equation and we should be done. So no fractions to clear here, but we have a lot of simplifying. The first thing we're going to need to do is the distributive property. We'll multiply 3 times 2x, we get 6x, and 3 times negative 7, that's negative 21, we'll write minus 21. Now don't forget the minus 4x, that's not part of what we did here. So it's important that you know when you're simplifying that includes getting rid of parentheses. We did that here by distributing. On the other side, we have 12 minus, now this is a 1, or it's understood to be 1, and so what we're really doing here is distributing a negative 1. Well, when we multiply by negative 1, that just changes the sign of each term. Negative 1 times x, this becomes minus 1x, or just minus x. And negative 1 times negative 3 would be a plus, or positive 3. We'll write plus 3. So notice a minus in front of parentheses has the effect that it changes the sign of each term in the parentheses. And that's what happens when you multiply by negative 1. Now we're not done simplifying. Notice on the left we can add our x terms together. We can only add like terms, and 6x and 4x are like terms. It's a minus 4x, so 6 minus 4, we're going to get 2x minus 21 is equal to, notice on this side we can add the 12 and the 3, that's 15 minus x. Alright, so now we've simplified everything that we could on each side. These are not like terms, so I'm done on the left. Same thing on the right. So now notice I do have the problem, remember isolate is next. I do need to get x on one side only, so I'm going to get rid of the x on the right by adding 1x. Whatever you do on one side, you got to do to the other. We'll get 3x minus 21 is equal to 15. So notice we did CSI, and we ended up with a two-step equation. Remember, we always add or subtract first with those. So we'll add 21 to each side. These cancel. You get 3x is equal to 36. You can divide both sides by 3. Hopefully you know that 3 times 12 is 36. And so 12 will be our solution here. All right. So that's just a quick review of solving equations. Let's move on to finding zeros. Notice our definition here for a given function f. If f of c equals 0, then c is a 0 of f. Now the first thing I want to remind you of is that this is function notation, and really f of x is just another name for y. You might be more comfortable with y equals 2x plus 7. F of x is just a different notation. And so y and f of x represent the same thing. X is your input, f of x or y is your output for this graph or this function. All right, so we need to find out when 2x plus 7 is equal to 0. So what we do is we actually set the function equal to 0. So if I'm trying to get x by itself, notice this is a two-step equation. I'll need to divide by 2. I'll need to subtract 7. We always add or subtract first. So we get 2x is equal to negative 7. I need to divide by 2 next. And so x is negative 7 halves. And so this is my 0. So what does that mean? Well, you could always plug it in. F of negative 7 halves equals 2 times negative 7 halves plus 7. Well, 2 times negative 7 halves is actually negative 7 plus 7, and notice you do get 0. So this is an input value that causes your output to be 0, and that's why we call this value, negative 7 halves, a 0 of the function. When you plug it in, it causes the function to equal 0. All right, so you might want to try B and then watch the video. All right, so now g of x is just like f of x. We're just using a different letter. H of x is also commonly used for functions. And so again, I want to know when 3/4 x minus 12 is equal to 0. So the first thing I think I want to do is move that 12 to the other side. Now, there's a couple of ways you could do this problem. We'll talk about clearing fractions later, but that's one way that you could solve this. I think what I want to do is, I'm not going to use my CSI here, although you could. I'm going to move that 12 to the other side by adding 12 to both sides. And then I wanted to show you this, if you haven't seen this or you don't recall this. You can actually solve this in one step. You have to ask yourself, how can I get a 1x? Well, if you multiply 3/4 by its reciprocal, 4/3, that's going to give you 1x. You'll get 12 over 12 when you multiply across. And so you do get x. And so we have to also multiply 4/3 times 12. So this is going to be 48 over 3, which is actually 16. So that's one way that you can solve that. So our 0 here is 16. All right, let's move on to problem solving. So throughout this course, we'll have this approach to problem solving using algebra to solve problems. That's our goal here, and this is an algebra course, and that's why we're doing that. We're starting with some pretty simple problems, so you might be able to do these using arithmetic, but our whole goal here, our main goal, is learning how to use algebra to solve problems. And so here's going to be the approach that we're going to use. Number one, we want to read the problem carefully to make sure we understand what it's saying, what it's telling us, what it's asking us to find, and we're also going to strategize. Not sure I spelled that right. Strategize. Maybe I did. What facts do you know? What are you being asked to find? Is there a formula that applies to the problem? Will a picture or chart help? So that's part of your strategizing, problem solving. So once you feel like you got a handle on the problem, you want to name the unknown, determine the unknown quantity and use a variable to name it. Any other unknown quantities should be expressed in terms of the same variable. You're going to write an equation that fits the problem, basically models the problem. You'll solve the equation. And once you have your answer, you want to make sure that you're actually answering the problem and make sure your answer makes sense. If you can make some sense out of it, then, or check your answer, then you're going to be confident that you did the problem right. So common errors in problem solving include misreading the problem. I think a lot of times we go too fast. You know, you can't really speed through a lot of word problems. It may take some time. Copying something wrong, using the incorrect equation, computational error, a basic reasoning error. These are the kinds of things you got to watch out for. So we're going to start with two very basic problems. Rather than giving you a whole bunch of problems and running through them, I want to hit two problems, and you'll be doing problems like these in the homework. I can't remember, you may see one that's a little bit different. You know, in the beginning, you might find yourself kind of just being a copycat, trying to follow the same process, but you want to try to make sense out of things, and ultimately, you want to be able to take the skills that you have here and apply them to new situations. And so let's go ahead and look at number 5. It says, Khalid makes an investment at 4% simple interest. At the end of 1 year, the total value of the investment is $1,560 in principal and interest. So you're going to have the money you invested plus interest. How much did he borrow? Actually, let's see. this really should say how much did he invest. Let me just double check here. Yeah, I don't know if I copied that wrong or what happened there. So he invested some money at 4%. Now remember what that means when you're earning 4% interest. So for example, first of all, if you're getting 4%, if you invested $100, at the end of the year, interest is normally paid per year. At the end of a year, you're going to get 4% of $100, which is $4. And so now you'll have $104. So that's the idea here. So at the end of 1 year, and so that's what's happening here. It's been in the bank or wherever for a year, and now it's worth $1,560. That's including the principal or what you originally invested and the interest. All right, so we're finding out how much was invested. So let's call that X. So the amount invested. And think about this, the amount invested, we're just kind of reasoning this out, plus the interest, that's what's going to equal this 1,560. So how much was invested? That's what we don't know, that's X. Our interest, well, we're getting 4% interest. It's 4% of what? Well, it's got to be 4% of what we invested. Now, sometimes people will just write 0.04. That just means you're adding 4 cents to what you invested. That's not correct. It's 4%, which we write as a decimal, of the amount invested, which is X. And that's what's equal to 1,560. Now notice these are like terms. You're going to add 1 and 0.04. So 1.04x is equal to 1560. We'll divide each side by 1.04. We're going to get x is equal to $1,500, which you might have guessed. And so our answer here is $1,500. Now I want you to notice how easy this would be to check. First of all, this makes sense. You would have invested less than what your money is currently worth. So if we take our equation and we have 1,500 plus 4% of 1,500, does that equal 1,560? Well, you can go ahead and do the math and you'll find that that is true. And so like I said before, if you're checking your answers, making sure it makes sense, then you're much more likely to be successful like when you do it on a test. All right, let's look at this last problem. It says the width of the soccer field recommended for players under the age of 12 is 35 yards less than the length. The perimeter of the field is 330 yards. Find the dimensions of the field. So here's a problem where we're going to have two variables, length and width, and we're going to want to label all of our variables using one variable. So let's see how that might work. So first thing I'm thinking is I want to draw a rectangle. I want to visualize what's going on here. Now when we do these kinds of problems, the width is normally the shorter length and the length is the longer side. And when we start naming variables, we'll usually start with the smaller length. And so since this is our width, why don't we use W? So W is equal to the width. Now it says the width is 35 yards, so width is 35 yards less than the length. So let's see. It's actually the way that this problem is written. Let's go ahead and do this. Let's just translate this. The width is equal, when we say is, that means it's equal to, the width is or is equal to 35 yards less than the length. So it's the length minus 35. So 35 yards less than the length. And so this is kind of an exception to the rule. Like I said, we'll normally call the shorter side the width. But notice here, if we call this L, the longer side, we know that the width is L minus 35. So you really could label this W, and this would actually be W plus 35, so this is not the only way to do it, but because of the way it's written, this is how I've written it out. This is how I've defined my variables. Okay, so W is, or the width, is actually L minus 35, and the L is the length. As long as things are consistent here, you can see that the width is smaller by 35 yards in this case. Now the other thing is we do have, there's a couple things you could do here. You could write L minus 35 here and L here. Of course, perimeter, you just add up these sides and you're going to get 330. So that's certainly one thing that you could do. I'm going to go ahead and use the formula that we have for perimeter, which is the perimeter is 2 times the width plus 2 times the length. And so either way, you can write an equation to represent what's going on here. So in this case, we have 330 is equal to 2 times the width, which we're calling L minus 35, plus 2 times the length. Well, we said the length is L, so we'll just leave it as L. And so notice now we can solve for L because we only have one variable here. So I'm going to switch the sides here. So 2 times L minus 35 plus 2L is equal to 330. We'll get 2L minus 70 plus 2L equals 330. I'm going to move over here. Of course, 2L and another 2L. Now, notice we're in the simplifying process. I just switched sides going from here to here, and now I distributed. And I can combine like terms. This is all part of simplifying. We'll get 4L minus 70 is equal to 330. This is a two-step equation. We need to add 70 to both sides. We get 4L is equal to 400, which means the length is 100. Well, that means, excuse me, that the width is L minus 35, or 100 minus 35, or 65. So the width we just found to be, 65. And this is yards. The length we found to be 100 yards. Now let's just double and make sure that this checks. So certainly the width is 35 less than the length. 100 minus 35 is 65. Also, if we take two widths, so 2 times 65 plus 2 times the length, which is 100, we should get a perimeter of 330. And I keep wanting to write that 330. So 2 times 65, that's 130. 2 times 100, that's 200. and that does equal 330. And so you can see this is quite easy again to check. All right, so that's it for this section. I hope that helps.